Hello. Thanks for clicking on this bonus pre-narculus production. Today, I am simply going to do some extra examples of partial fraction decomp type 1 for those of you who are having some trouble figuring out still how the process works. Sometimes it takes people more than 2 examples to figure it out, but I didn't want to make a video that was over 30 minutes to do it. So here are a couple of extra examples if you're still having trouble. Okay, it's the same thing. We already know how to do this. So, and if you don't, here's a couple more examples to try to figure out the whole process. All right, so the first thing you're going to do is you want to decomp this. You need to factor the bottom. So the bottom factors with difference of 2 squares, x minus 3x plus 3, leave the 6x on the top. Now you need to write down your 2 factors or your 2 fractions that you can make out of this. One of them could have a denominator with x minus 3, and the other one could have a denominator with x plus 3. Okay, on top of the x minus 3, this is a linear factor, so all you can put up there is a number, a. Okay, I don't know what number it is, I got to call it something. Over here, same thing. I have another linear factor. All I can put on top in the numerator is a number, but it doesn't have to be the same number as this one. It could be different, so I'm going to call it b. Okay? Now, next step, you are going to combine your 2 fractions. Find a common denominator and put these back together, these 2, okay, with the a and the b. So this term would need an x plus 3 on top and bottom, and this term would need an x minus 3 on top and bottom. So that would give me, I'm going to bring this 6x, x minus 3, x plus 3 down. That would give me a, x plus 3, plus b, x minus 3, over x minus 3, x plus 3. Okay, now I want these 2 to be equal to each other. Right? I want these 2 fractions to be exactly the same. Well, the denominators already are exactly the same. So what I really want to be equal are the numerators. So I need 6x to be the same as a, x plus 3, plus b, x minus 3. Okay? So now I'm going to pick strategic values of x so that I'll zero out either a or b. So I'm going to let x be -3. If I let x be -3, when I put it in here, it gives me 0. 0 times a will be 0, and a will drop out. So I'll have 6 times -3 on the left equals -3 plus 3 is 0. 0 times a is 0, so I don't need that. And then I have b times -3 minus 3. So I have -18 equals -6b. So b equals 3. Okay, that gets me b. Now I also need a. So I'm going to have to pick another x. So let me come back over here. I'm going to let x be 3. Because if I let x be 3, then 3 minus 3 is 0. 0 times b is 0. Then b disappears. And then I'll be left with a to solve for. So I have 6 times 3 equals, let's see if I can squeeze it in here, a times 3 plus 3. Okay, putting 3 in for x. When I put 3 in over here, 3 minus 3 is 0. B drops out. So I get 18 equals 6a. So a is 3. So now my partial fraction decomp, come back to the fractions that have been split apart and put your appropriate letters. You're going to get 3 for a over x minus 3 plus 3 over x plus 3. And you're all done. If I combine these 2 fractions, I will get 6x over x squared minus 9. That's what I'm trying to accomplish. Okay? There's your problem done all the way. All right, I'm going to do one more example. This one's going to have an extra 3rd factor in it. which will make it exciting. So let's try 4 over x cubed minus 4x. All right, first thing you have to do, factor the denominator. Okay, like I said, the steps are the same no matter what it looks like. So, but then I can factor x squared minus 4, x minus 2x plus 2. Okay, now I have 3 factors in the denominator. All right, so now I could make a fraction that has an x in it. I can make a fraction that has an x minus 2 in it. And I can make a fraction that has an x plus 2 in the denominator. So now I have 3 fractions. On top of the x is linear. So all I can put here is a number, a. X minus 2 is linear, b. Doesn't have to be the same as that. X plus 2 is linear, c. All 3 of them could be different. So those are my partial fraction setup. Now, I need to find a common denominator. So now let me come down here and I'll find the common denominator down here. Okay. The common denominator should be the easiest part of the whole thing because it's the same denominator that's up there. X minus 2, x plus 2. So this first term has an x. It needs an x minus 2 and an x plus 2. So this will be a, x minus 2, x plus 2. Plus the b needs an x and an x plus 2. bx, x plus 2. Yeah, I don't know if you can read that. So bx, x plus 2. And then the c needs an x and an x minus 2 to make the common denominator. c, x, x minus 2 to make the common denominator. Okay, all of that over that. All right, now, if you go back to your step before, we have this. So let's write it down here. We want 4 over x, x minus 2, x plus 2 to be equal to a, x minus 2, x plus 2, plus bx, x plus 2, plus cx, x minus 2, all over x, x minus 2, x plus 2. But if you look at the two fractions, these two denominators are already the same. I don't need to make them equal. They already are. So I'm going to erase the denominators down here. It's going to save me a line of work, so I don't have to rewrite this 1,000 times. So I'm going to erase the denominators. And all I want are for the numerators to be equal. I need 4 to be equal to that disaster that's over here on the right. Okay? Now, again, you got to start picking strategic choices of x to try to knock out some of the variables. So I'm going to pick 2. And if you look, 2 will knock a out, right? Because you'll get a 0 here. This will be 4, but a times 0 times 4 will be 0. Okay? If I put 2 here, b will still be in. And if I put 2 here, c will drop out. So then b will be the only thing left, and I can find b. All right, so on the left, there's no x to plug into, so I just have 4. On the right, a drops out. I get b times 2 times 2 plus 2, and then c drops out. So I'm going to come over here because I don't know if you guys can read underneath here. I think you can, but I'm not sure. So you get 4 equals 4 times 2 is 8, 8b. So b equals 1/2. Okay. All right. So now let me come over here, I guess, somewhere. I gotta find the place. Here, we'll put it here. B is 1/2. Okay. All right. So that takes care of that one. All right. Now I'm going to erase this and I'm going to start again. Start again now. So I am going to pick something else. I'm going to let x now be -2. If I let x be -2, then a will drop out. -2 plus 2 is 0. So that'll knock a out. That'll knock b out because of this factor. But c will still be in. So I'll have 4 equals a drops out, b drops out, c times -2, -2 minus 2. So if I come across here, 4 equals -4 times -2 is 8. C is also a half. Okay. All right. This is complete happenstance that both the variables that you've done in both sets of problems, the numbers have been the same. They don't have to be. They just happen to be here. Okay. So that takes care of C. Now I need to find B. To find B, I need to, oh no, I found B. I found B, I found C. I need to find A. So I need to drop out B and C. So I got to pick something for X. So in this case, I'd pick 0 for X because when I put the 0 here, it's going to do 0 times B, it's going to be 0. So it's going to knock this B out. 0 times C is going to be 0. It's going to knock that B out. It's going to leave me with A because when I put 0 in here and 0 in there, neither one of them is going to give me a 0. So I get 4 on the left. Okay, there's no X to plug into. I have A, 0 minus 2, 0 plus 2. So I have 4 equals -2 times 2 is -4A. So that means A is -1. All right, so there you go. There's a number that's finally different. A is -1. Okay, there's my 3 values for A, B, and C. So now I just need to fill them in. Here is my decomp. I just need the numbers to go in there. Okay, so I'm going to show you a little something here real quick. So A is -1, so -1 over X, plus B is a half. It's a fraction. So what we do is, instead of writing a half in the numerator, we put the 1 in the numerator, the 2 goes in the denominator, and it's getting multiplied by X minus 2. So there's your 1/2 for B. And then C is also a half, so same thing. 1 in the numerator, 2 in the denominator, times the X plus 2. And this is your partial fraction. That is the correct answer. Okay, so there's an extra 2 examples. Hopefully you're starting to get the idea of how it works. It's the same thing every time. All right, it just is lengthy, but it is the same thing every time. Okay, all right. Thanks for clicking on these extras if you did. If not, well, you don't even know what you missed. Thanks for clicking.